In this video, I want to talk a little bit about area of a bounded planar region. And so for our purposes, what that looks like is finding the area of a region bounded by two curves. So this white area here, I'll call this region R. Let me put it in a better color here. So I'll call this region R, and I want to find the area of R. So I can do this by noticing that the area here, the white area there, is the same as if I were to take the area underneath F, all of this area, this blue area here, and subtract off all the area underneath G, so all that red area there. And you can see that, if I overlay this here, that this region here that I get by just taking the area underneath F and taking off the area underneath G is the white region that we want to find the area of. And we know that we can find the area of a region, the area underneath the curve by taking the integral. So what this tells us is that the area of R that we're looking for is equal to the integral from a to b of f of u du minus the integral from a to b of g of u du. Now the reason I say a to b is because a and b are where my two functions f and g meet. So f of a is equal to g of a, and g of b is equal to f of b. So those a and b values would be my bounds. Now, by the properties of integrals, I can rewrite this as the integral from a to b of f of u minus g of u du. Now the reason I used u is because I didn't want to necessarily say x or y, because if we're integrating with respect to x or y, we mean different things. So colloquially, we can write this area. If we're integrating with respect to x, we take the integral from a to b of top function minus the bottom function, dx. If we're integrating with respect to y, we take the integral from a to b of right function minus left function, dy. Okay, now let's apply this intuition here to a problem. So my question is, what is the area of the region bounded by f of x equals x squared and g of x equals the square root of x? So I'll draw f of x here in blue. So that's going to be x squared, so it's going to look something like this. It's going to be perfect. And then g of x I'll draw here in red, so it's going to be the square root of x. So that looks like this here. So I know that this is the region that I care about, this region here. It's bounded by the two curves. And in order to find that integral, I need the integral from a to b. If I want to integrate with respect to dx, so going vertically, I would take the integral from a to b of top minus bottom dx. Now that is going to be the integral from a to b of my top function is the square root of x, this red curve. So square root of x minus x squared dx, the bottom function being x squared in blue. Now I need to find my bounds. So I need to find my a and b, but my a and b happen where my f of x is equal to g of x, right? Where they intersect, where these two curves meet. So I set f of x equal to g of x. Now that looks like setting the square root of x, or I should write it this way, x squared equal to the square root of x. Cool. So I will go ahead and square both sides. So I get x to the fourth is equal to x. I don't want to divide by x, because if I divide by x, I'm assuming that x is zero. Or sorry, x is not zero. So I'll subtract x from both sides. And this will give me x to the fourth minus x equals 0. I can factor out an x, so I get x cubed minus 1 times x equals 0. So this means that either x equals 0 or x cubed minus 1 equals 0. So x cubed equals 1. So this implies that x equals 1. So my bounds here are 0 and 1. So I need the integral from 0 to 1 of the square root of x minus x squared dx. Cool. Okay, so evaluating this here, this is going to be the integral from 0 to 1, or I can go ahead and just evaluate it now. This is going to be 2/3 x to the 3 halves minus 1/3 x cubed, evaluated from 0 to 1. When I evaluated at 0, everything just zeroes out, so I only have to care about 1, so this is going to be 2/3 minus 1/3, and so that equals 1/3. So that tells us, all of this is to say, that this 1/3 here is the area of this white region here. So this tells me that A equals 1/3. Cool. Okay, so having done that in X, I want to see what does it mean to do with respect to Y. What if I get a dy? So let's think about this now. So I'm gonna go ahead and erase everything with X. So what if I integrate, instead of going vertically, let me redraw these here. Instead of going vertically, what if I go horizontally? So I want to find the region, again, the area of this region, but I'm going to integrate with respect to dy. So that means my rectangles are going to be in this direction, in the horizontal direction. So again, I need the integral from a to b of right minus left dy. Now I need my functions to be in terms of y. So I'll rewrite f of x. So f of x we'll say equals y1 equals x squared. So this tells me that x equals I'm going to take the positive square root because we're on the positive side here. The side that we really care about is positive. Is going to be the square root of y. And then we'll say g of x equals y2, and that'll be the square root of x. The square root of x. And now I can square both sides and get that x is equal to y squared. Cool. So from this, my right function is the square root of y, and my left function is y squared. So I can take the integral from a to b of the square root of y minus y squared dy. Now I just need to find my a and b. So again, I need when f of x is equal to g of x. So setting those two equal means setting x equal to x. So I need to know when the square root of y equals y squared. We already did this one, so squaring both sides, I get y equals y to the 4th. Then 0 equals y times y cubed minus 1. This tells me that y equals 0 and y equals 1. So this integral becomes the integral from 0 to 1 of the square root of y minus y squared dy. And if we compute this integral, it's the same as the integral we had before, but now it's just with respect to y, and we will end up getting, again, 1/3. So we can do it either way. Okay. Next, I want to find the area of the region bounded by f of x equals sine x and g of x equals cosine x. So I'll go ahead and graph these. My first step is to always draw a picture. So sine x is going to look something like this, and maybe not exactly like that, but like that. And g of x is cosine of x, so it's going to look something like this. And my region is going to be bounded by sine x, cosine x, and x equals 0. So the line x equals 0 is the y-axis. So this is the region I want here. So I already get a for free. A is going to be 0. And I'm going to integrate with respect to x because that's going to be what's easiest for me. So we want the integral from a to b of top minus bottom dx. And that's going to be equal to the integral. We already have that a is 0 to b. My top curve is cosine x in red there. My bottom curve is sine x in blue there, dx. Now we got to find b. So b happens when f of x equals g of x. That's when the two curves overlap. So I need sine x to equal cosine x. Now, if you're familiar with trig, you'll know that this happens between 0 and pi over 2 when x equals pi over 4. So Pi over 4 means that sine is root 2 over 2, and cosine of pi over 4 is also root 2 over 2. So they're equal. And now I know that this b is pi over 4, so I can compute my integral. This is going to be positive sine of x plus cosine of x evaluated from 0 to pi over 4. So that is going to be sine of pi over 4 we just said is root 2 over 2, and cosine of pi over 4 again we just said is root 2 over 2, minus sine of 0 is 0, cosine of 0 is 1. So we get this. So this is root 2 minus 1. And that would be the area of that region shaded in white there. And that kind of wraps up what I wanted to say about area bounded between two curves.